Alright guys, so 3-5 basic matrix operations. Again, these are brand new topics within our class here, and I promise, despite sounding strange, they are rather easy, okay? Basic matrix operations. So our essential question is, how do you add, subtract, and scale matrices? Okay, basically the new things we're looking at are called mathematical matrices. They organize numbers in a nice little array, and we always specify them. Here's one key thing: rows by columns. There's a little jingle online: rows by columns, rows by columns. Okay, hopefully you remember that now. They are the number of rows, row, 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 by the number of columns. Okay, so this first matrix we're going to call a 3 by 2 matrix. This next one, row, 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 column, 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 is a 3 by 3. If it's the same thing, we call that a square matrix, okay, because it resembles a square. Here we would have a 2 by 2, and here we would have a 2 by 3. So do definitely know rows by columns is how we look at them, okay? That's going to be very important later on. This photo, by the way, is from the Matrix movie. Okay, it's a little older now, but please, if you haven't seen it, I'll be referring to it several times coming up. You should check it out. Addition and subtraction, matrices must be the same dimensions, okay? They have to be a 2 by 2 plus another 2 by 2, etc. Okay, or a 3 by 3 plus a 3 by 3. They have to be exactly the same. And for scalar multiplication, it's kind of like scaling a picture, we'll find. Okay, now we really don't need our calculators for these basic operations. I will show you how to use your calculator, but simply you're going to take each section and add it to each section. So it's so easy. Matrix addition, you're going to take the top left, okay, and add it to the top left. So it's going to be -2 plus -3. Oh my goodness, you're like, Mr. D, really? It's that easy? -2 plus -3 is -5. Okay, you'll take the next number, 5 plus 1. Well, that's 6. Okay, and so on. 11 and -5 is another 6. 4 and -2. Oh boy, 2. -6 plus -8, -14. And 8 plus 4, 12. That is all for matrix addition. Okay, now be careful subtracting. Same idea, only subtracting. So we'll take -4 minus 2. Okay, we also like to write our matrices with the little brackets. Okay, and just be neat. So -4 minus 2, that's -6. 0 minus 2 is -2. 7 minus -3. Okay, so be careful. 7 minus -3 is really 7 plus 3. So we'll have 10 here. Negative 2 minus 0 is just negative 2 again. And negative 3 minus 5 is negative 8. And 1 minus negative 14 is 15. Okay, be careful there. This next part is called scalar multiplication. Okay, and it's called, there's different things. There's a different multiplication we'll look at later. It's like if you were to scale a picture, or quickly here, so like if you scale a picture, sometimes it starts out small, but if you scale it, okay, you increase it, you increase it, you increase it, you increase it, okay, that's why we're scaling each of the numbers. So it's simply taking 4 times all of the values. So 4 times negative 2 is negative 8. 4 times negative 8 is negative 32. 4 times 5 is 20. And 4 times 0 is 0. Scalar multiplication. We can combine the two things in one, okay? Wow, we just scalar multiplied there, sorry. But combining everything at once, we can scale and then add. So first we'll scale everything here. So 12 minus 3, negative 9, negative 15, boom, boom, plus negative 2, 0, 6, equals, adding each spot, 10, negative 5, negative 9, and negative 9 again. Okay? Easy peasy. It does get a little more challenging with what I ask you to do next, and that's solving matrix equations. Just know that each cell is equal to its counterpart. So when you see this equal to, each spot is equal to the corresponding spot on the left. Now first we have some work to do, okay? First we will do these inside operations. Okay, before we scale even. Okay, so before we even scale, we're going to have 3 times the quantity. What is 5x plus 3? Well, that's simply 5x plus 3. Rewrite it like that. Don't get scared. It's just a part of our matrix. Also, negative 2 plus 7. Well, that number there, that's just a silly old 5. Okay? 6 plus negative 5 is 1. And negative 4 plus negative y is negative 4 minus y. Okay, now we can scale our single matrix. It's just easier to do this way. Okay, so 3 times the quantity, 5x plus 3, that's really 15x plus 9. 3 times the 5 is 15. 3 times 1 is 3. And 3 times this cell is negative 12 minus 3y. Now notice, all of our distributing properties held true. So I have to distribute to the quantity and to the quantity. Now, getting to the more challenging math of the day, and really it's super duper easy again. So we know that these two matrices are equal. They are equal to one another. We just don't know how, okay? But what we do know is that top left is equal to top left. So 15x plus 9 better be negative 21. Okay, top left equals top left. Well, if we just solve for x, this is a negative 21, sorry, negative 30 equals 15x. Well, hey, x is really negative 2. X is solved for. Now notice also, our other parts of the cells, 15, 15, they're the same. 3 and 3, they're the same. Bottom right must be the same as bottom right. So again, negative 12 minus 3y better be negative 24. Add 12, add 12, and y is equal to 4. So it's like solving in matrices. So we just solve for x and y. Okay? First, so if you want to try on the challenge of example 5, first again, add what's inside, and then worry about distributing. Okay? But really, that is the basic idea. So know that each part is the same as each part. You can certainly answer the EQ right on now. If you have extra time, though, I am going to go through these other two. So here's the extras.